Hello, everyone. Good afternoon. Welcome to this Nestlé Health Science Industry Symposium entitled How Do Human Milk Oligosaccharides Modulate the Immune System in Infants with Cow's Milk Allergy, Emerging Evidence and Clinical Implications. My name is Alexandra Santos, and I'm a professor of pediatric allergy at King's College London, and I'm delighted to chair this session and to have with me world-level experts in the field talking about a variety of interesting talks around this topic. So we'll start with Professor Liam O'Mahony, who will talk about mechanisms of human milk oligosaccharides in modulating immune response.
Thank you, Alex, for the introduction. So first of all, here are my conflicts of interests. I'm delighted to speak to you about the development of the early life microbiome. So we're all born sterile, so we start to pick up microbes through the birthing process. The first round come from mums and the local environment. And then over the months that follow, microbes that come from other sources like older siblings, the wider family network, pets, environmental sources, they all become much more important. But actually today there's a number of limitations to us picking up many of these microbes, from the use of antibiotics to smaller family sizes. And perhaps most important for today's discussion is around when you get these microbes, they have to be supported by something. And what they're supported by is diet. And human milk oligosaccharides, as I'll go into, is one of the most important early supporters of some of those early microbes, especially bifidobacteria. So at the same time that the microbiome is developing, we know the immune system is developing. And as we heard this morning from Peter Broden's talk, it's not that the cells, the early life immune cells, can't respond, but actually how they speak to each other is different. So they have to learn to communicate properly with each other, and they have to learn how to communicate in concert with each other so they can be very effective and regulatory networks that can be established. And of course, we would say who's the conductor of this? It's the microbiome. And it's the microbiome composition as well as its metabolic outputs that are coordinating and driving the development of these communication pathways between the immune system cells early in life. And just to show you how important the microbiome is for that early life, or say how important diet is for the early life microbiome development, this is a study that is not published yet, but we looked at the variance in microbiome composition between kids at 6 and 12 months of age. And basically what I'm showing you over here on the left is that 20 to 25% of the variance, or the difference between kids, can be explained by their diet at both 6 and 12 months of age. And when you compare that to things like C-section delivery, which is very, very important, it's far less important in determining the composition of the microbiome early in life. And when we look at those dietary factors, I know this is quite small here, but the main standout dietary factors that's contributing to this microbiome development is breastfeeding, and then followed by other plant-based foods like sesame, legumes, beans, and so on. But breastfeeding is standout alone as the most important contributor to that early life microbiome development. And what is it in the breast milk that's driving that? So one of the most important factors are the human milk oligosaccharides, the HMOs. These are basically sugars that are chemically modified in such a way they're unavailable to the host for energy use. But they're available to certain bacteria that have very specialized enzymatic systems that can degrade and digest and utilize this source of energy. There's many different HMOs have been identified, over 150 different types. And its composition can be, or the HMO composition of a mum's breast milk can be very, very different depending on many different factors. And this can be important for outcomes such as food allergy. So here are examples of two different studies in looking at HMO composition of breast milk and looking for an association with risk of food allergy, or in this case, cow's milk protein allergy in offspring. And there is an association. And one of the things that we would suggest is that association is mediated via the HMO effects on the immune system, either directly or directly via the microbiome. And I'll show you some examples of how that might occur in a moment. But it's not just about allergy. It's also infection and infection risk is very important. So this is one study where kids were given 2 HMOs, and their early life incidence of things like bronchitis or use of antibiotics was significantly reduced in those kids that got HMOs early in life. And I'll talk a bit more about some of the mechanisms by which we think that may be mediated. So I want to come back to something I mentioned at the beginning, that the microbiome is important both for effector as well as regulatory responses. And so I think something that will improve regulatory responses, of course, is important for allergy prevention, but also you need an effector response to protect against infection. And that regulatory response will keep that anti-infective response in check, so it won't overreact. So these are all connected responses. So what are the mechanisms through which HMOs may modify allergy risk as well as infection risk? So number one is HMOs can be utilized by specific microbes, so you get expansion of those, so I'll go into that in a bit more detail in a moment. In addition, HMO utilization by microbes generates different metabolites that can then have an effect on the immune system. And thirdly, HMOs can have direct effects on both epithelial as well as host immune cells. So HMOs can have direct as well as indirect effects via the microbiome on the host immune system. So let's start with the direct effect, or the indirect effects, by increasing the levels of microbes in the early gut. And I guess my favorite group of microbes are bifidobacteria, and selected group bifidobacteria are very good utilizers of HMOs. So this trend line is a trend line from nearly 4,000 infants, and it's just showing the average bifidobacterium levels in the first 4 years of life. And as you can see, they peak between a couple of months of age up to maybe 1 year of age, and then they start decreasing. Or up to, 3 months of age, and then they start decreasing. The box plots are from one study that we recently did looking at kids born during the pandemic. So these were born during a lockdown period. And actually they have more bifidobacteria at 6 months, but really a lot more at 12 months compared to this trend line. So why might that be? So actually in these kids, there was a hugely increased rate of breastfeeding and a reduced rate of antibiotic usage. And the numbers are here. So in the coral cohort, the cohort born during the pandemic, which has higher levels of bifidobacteria, 53% of mums were still breastfeeding at 6 months of age. And in an Irish context, that would normally be 15%, so it's way higher. And 35% were still breastfeeding by 12 months. And if you look at the antibiotic numbers, only 7% had an antibiotic at 6 months, and only 17% had at 12 months of age. And previously, that number would be about 80% of kids. So we think those two factors, and I think this is a really good example of how maybe a lifestyle change in one way can very positively impact that early life microbiome, particularly around BIFs. So more breastfeeding, more HMOs, more BIFs, and we think that's a good thing. And why do we think BIFs are so important? So many people have looked at BIFs, and I'm just going to show you some examples from our own work. So this was a germ-free mouse model, which we gave 2 different infant-derived bifidobacterial strains to the mice. And germ-free mice have very low levels of T regulatory cells in the gut, but you can see the mice that got this bifidobacterium, you have a huge expansion of T regulatory cells in the gut. So we think some of these BIFs are really important for T regs. But as you can see, not all BIFs do it. So this bifidobacterium strain didn't have any impact on T regulatory cells in the gut, but actually it colonizes to the same number of cells. So it's not that it doesn't survive, but it doesn't engage in the same way with the immune system. Also, if we take these cells from these mice, we put them into mice that we cause inflammation. In this case, we're infecting mice with salmonella, and we're causing this huge increase that we can visualize in NF-kappa B activation. These bifidobacterium-induced T cells dampen down all these inflammatory activities. And it doesn't really matter how we induce this inflammation, it's always dampened down. And then if we go to humans, we've done a lot of human studies with this bifidobacterial strain. Excuse me. And in this study, it was an 8-week feeding study, and when we looked at IL-10 secretion after 8 weeks, everybody that was fed the bifidobacterium had an increase in their IL-10 secretion. And on average, there was a 10 to 15% increase in the numbers of circulating T regulatory cells. So it's not just in mice, it also seems to be in humans that bifidobacterium engage this regulatory immune response. Some bifidobacterium, not all. And how do they do that? So the bifidobacterium themselves, and particularly some of these early life bifidobacteria, are covered by these extracellular polysaccharides that we think are very, very important for their immune regulatory effects. So in this particular one, I'm showing it here, we knocked out the extracellular polysaccharide. And what we could show when we co-incubated these cells with monocyte-derived dendritic cells from humans was that we now got a TNF response, a pro-inflammatory response to the microbe. But when the EPS is on the cell surface, we don't get any TNF response. And these numbers here are, that's 100 bacterial cells to one dendritic cell. So an awful lot of bacteria. When the EPS is on there, you don't get any TNF response. But when you don't have the EPS on the microbe, now you get this pro-inflammatory response. And we even took that further to look in mouse models where we isolated the EPS, we put it in the nose of mice. And when you look at an allergic airway disease model, you have a lot less eosinophils coming into the nose of these mice. And that's, excuse me, dependent on TLR2 and IL-10. So just as an example of one of the factors that's associated with the cell wall of bifidobacterium that seems really, really important for the immune system. But again, it's not just about allergy. So this is a lethal influenza model in mice. It's a H1N1. It's a mouse-adapted influenza, and 100% of these mice die between day 8 and day 9. But if we give one shot of this bifidobacterial cell wall into the nose of the mice, it can be either before or after infection, it doesn't matter, about 50 to 60% of the mice survive. And these mice have actually cleared the virus, so it's not that they die a day or two later. And if you look at the viral titers here, you can see the huge kickoff in viral titers that happen in the placebo mice, whereas you don't get any increase in the viral titers in these bifidobacterial treated mice. And when we look at cytokine levels in the lungs of these mice, what we can see, it's not that there's a dampened immune response. Actually, early, there's a much more pronounced immune response in the bifidobacteria treated mice. But then when you get a bit later, it switches. So the placebo mice now have this huge immune response, whereas the bifidobacterial treated mice have a controlled immune response. So you have this early effective dealing with the virus and a controlled immune recovery thereafter. So that's the BIFs. And what about the second one, which is metabolites? So I know Ralf is going to talk about the study in much more detail later. I just wanted to mention it here. This is a study, again, done with HMO supplementation in infants. And what these authors did was they did metabolomic profiles, and you can see a whole range of different metabolites changed with HMO supplementation. Even things like 12,3-dihome, which was shown by Susan Lynch's group a couple of years ago, that it was a negative regulator of T regulatory cell induction in the gut. And HMO supplementation reduced the levels of this molecule. But again, I'll let Ralf talk about this in more detail later. But the other class of metabolites that we all know and love are short-chain fatty acids. So these are acetate, propionate, and butyrate. They can be made by a whole variety of different microbes. There's multiple different enzymatic pathways to make them, and I'm not going to go through all of these today. But I suppose the main point is that these engage with host cell receptors like GPR109A, 43, 41, and also they're important HDAC inhibitors, so they influence epigenetically the immune system. And all of these effects actually induce a regulatory response and protect against allergic sensitization. And other authors have shown they have really good effects against virus infection of the respiratory tract as well. And we already had shown a few years ago that actually having a high level of these short-chain fatty acids early in life is associated with a much lower rate of allergen sensitization. So this is correlating those kids with the highest levels versus the lowest levels of butyrate, propionate, or acetate at 1 year of age, and then their allergen sensitization by 5 or 6 years of age. And that's to any, both aero as well as food allergens. And even if we look at some disease outcomes, those kids with the highest levels of butyrate, they have a lot less asthma, allergic rhinitis, and food allergy. Whereas those with propionate or acetate, the outcomes were not as significant as what you see with butyrate. Really seems to be the one that's important. So that's an example of a metabolite that's secreted by microbes following HMO supplementation. And then lastly, what's the direct effects of HMOs on these cells? So HMOs can actually provide decoy receptors for certain pathogens. And we decoy receptors for the human blood group antigens. So pathogens bind to the HMOs rather than binding to the host receptors on host cells. HMOs have been shown to have a direct effect on epithelial cells and have an effect on epithelial barrier function. HMOs can be directly recognized by some innate immune cells through pattern recognition receptor, such as through toll-like receptor 2 or DC-SIDE, the C-type lectin receptor. And this results in cytokine secretion and a cell activation program that influences many other different cell types downstream of this direct activation. And finally, very recently, HMOs were shown to directly stimulate IL-22 secretion from intestinal dendritic cells. And IL-22 is a really critical barrier cytokine within the gut. So to summarize, what I hope I've shown you is that human breast milk contains many immunomodulatory and microbiome modulating factors, but HMOs are one of those, and we would suggest they're one of the more important ones. These HMO effects can be direct or indirect, so direct effect on cells of the host, or indirect perhaps through microbial expansion or microbial metabolism. And we think that the development of the immune regulatory and immune effector, so both go hand in hand, are really impacted by HMOs. So thank you for your attention.
Thank you very much, Liam, for this very insightful and exciting talk. And we'll move on to the second talk of the session by Professor Anna Nowak-Wegrzyn, talking about clinical implications of 2FL and LNT in the nutritional management of cow's milk allergy.
Just touch it. Okay. Thank you, Alex, for this introduction. Thank you for having me today. I will be sharing some of my experience as pediatric allergist, and here are my disclosures, and I do receive honorarium for this presentation from Nestlé. So here are my objectives. I'll talk about, just to refresh your memory, that cow's milk protein allergy is an immune-mediated disease. We'll talk about the role of HMOs, particularly for children with cow's milk protein allergy, and then review the evidence from clinical studies on adding two HMOs, 2FL and LNT, to the hypoallergenic formulas, both extensively hydrolyzed and amino acid-based for children with cow's milk protein allergy. So cow's milk protein allergy is an immune-mediated disease. It could be IG-mediated or non-IG mediated, and it is one of the most common food allergens, affecting maybe 2 to 3% or even higher in the first year of life. The treatment at this point is avoidance and substitution for the eliminated nutrients. For every infant, the first year of life is the critical time for development of the immune system, and also of the maturation of the gastrointestinal tract, the intestinal barrier, the digestion, and it's heavily influenced by establishment of healthy microbiome. And we know that children with cow's milk protein allergy have also reactions in the gut, so local immune reactions, which suggest that there's a defect at the mucosal level. And very simplistically, we think cow's milk protein allergy reflects overactivation or overexpression of the Th2 immune responses over the normal anti-infected Th1 immune response, increased gut permeability, as well as altered gut microbiota, so dysbiosis. And what's relevant to my presentation is also to remind you that infants and children with cow's milk protein allergy are at a very high risk to develop infectious complications, predominantly lower as well as upper respiratory tract infections. And this is, reflective of that imbalance between the Th1, Th2, also delayed maturation of the Th1 response in addition to that imbalance. So normally there's a maturation of the immune system over the first 3 to 5 years of life, and children who are born with predisposition to atopy have much delayed maturation. What does it mean that those children have more infections? it means that unfortunately they're being treated with antibiotics. So although we know that most of the infections in infancy are viral etiology, yet children are being treated with antibiotics. So on average receive up to 3 courses in the first 3 years of life. So, and we know that this reflects this impaired immunity, Th1 immunity, and the gut environment plays a big role in that. So maybe I'll not go into detail over this slide because Liam beautifully explained how do HMOs support the development of the immune system in infants. And this is true for all infants, but also for children with cow's milk protein allergy. So they promote healthy bifidobacteria, which are predominant bacteria communities present in the stool in the gut of healthy breastfed infants. They assist gut barrier function, so they improve intestinal permeability, so leaky gut. They provide this pathogen exclusion, so maybe that's one of the components of the protection from infections. And then, as Liam pointed out, they also have the ability to directly stimulate the immune system, either through activation of the dendritic cells that then produce IL-10 and activate the T regulatory cells, or production of other types of cytokines like IL-22. So on to the clinical evidence from the clinical trials. So the first study was a study which was done to prove that adding HMO to hypoallergenic infant formula does not change hypoallergenicity. So always whenever there's a new component added to the hypoallergenic formula, there's a concern whether there is a cross-contamination during process, during production. So it was a study that was done in the US, multi-center clinical trial, which actually included a lot of children with IgE-mediated food allergy. Those are infants and children up to 4 years of age. The test formula was Altera, and this formula has similar concentrations of 2-FL and LNNT that are found in human milk. So those are two sort of very important HMOs that are present in, I think, account for about 30% of all of the HMOs. They're very high in breast milk in the early early life. Those are selected for inclusion. And this study confirmed hypoallergenicity of this extensively hydrolyzed whey-based formula, which was actually manufactured with a non-porcine-derived enzyme blend. So I will not go over this in detail, but essentially there was a double-blind placebo-controlled challenge, which means one session of the challenge was feeding with the formula with HMO, and the second session was feeding on a separate day, was feeding with the formula without HMO, and the reactions were evaluated during the challenge. American Academy of Pediatrics had formulated or defined allergenicity for defined criteria for hypoallergenicity of infant formula, that it should be tolerated by 90% of children with cow's milk protein allergy under controlled conditions such as during oral food challenge. So we have shown that the formula, both test and control formula, were tolerated by over 98% of the participants in the trial, which were children exclusively with the Ig-mediated food allergy. So that was just one time, so it didn't really give us, we determined a formula is safe. So now on to the studies that included longer feeding with the formula over a longer period of time. And actually, this study was designed to look at the growth in infants with cow's milk protein allergy, not specifically looking at the infections in those infants. So the new formula with HMO actually has a reduced protein level. So there is a big concern whether lowering protein in the formula is going to translate into suboptimal growth in those infants. So this was a non-inferiority trial design which compared feeding with the formula with and without HMO over several months. But among the secondary objectives, there was assessment of tolerability, safety, infective morbidity, and medication use over the study period. So it was a large clinical, multi-center clinical trial that enrolled and randomized 194 infants, 1-to-1, and there were some dropouts from the study, about 15-20%. The result was positive in terms of the non-inferiority, so there was similar weight gain and growth, longitudinal growth in infants fed with the test formula with lower protein content. There was no difference, so both formulas were very effective in helping the symptoms, because symptoms resolution across all of the time points was not different. And what was very relevant to my presentation, there was reduced frequency of upper and lower tract infections as well as ear infections at 12 months in the per-protocol analysis. So there's also some reduction in the lower respiratory tract infections and gastrointestinal infection, although it wasn't statistically significant. So the primary endpoint of the study was growth, and maybe I hope you can see the lighter green is the control formula, the dark green is the test formula, and you can see that they sort of track very closely for weight and length. But the outcome, secondary outcome of the infection reduction was also very interesting. So you can see the results of the per-protocol as well as full analysis set, so intention of those infants who are enrolled. And by either type of analysis, there is a reduction in the frequency of the lower, upper respiratory tract infections, ear infections, also gastrointestinal infections, acute diarrhea. And looking at those infections, I should have mentioned that before studying this formula in infants with cow's milk protein allergy, there's a very interesting study that was done in healthy infants, which showed that there was a significant reduction in the lower respiratory tract infections and also antibiotic use in healthy infants who were fed with this formula since 2 weeks of age up to 12 months. In contrast, in the children with cow's milk protein allergy, those are infants who already developed symptoms before they were entered in the study, so they were enrolled at an older age, and the duration of feeding with formula was shorter, 8.8 months. So there was a relative risk reduction of 34%, but it was statistically non-significant. However, when looking at the frequency of the infections and reduction in lower and upper respiratory tract infections per month, there was a statistically significant reduction in the upper respiratory tract infections, which I think is very interesting, especially that these are the infections that are driving the unnecessary use of antibiotics and, making dysbiosis worse. The conclusions from the study were that the new formula, extensively whey-based, supplemented with 2FL and LNT with reduced protein content, supported normal growth, and then resolved the symptoms of cow's milk allergy within 1 month. And it suggested that there are some immune-enhancing properties of the formula supplemented with HMO, and in reducing the respiratory and ear infections. So Professor Heine is going to really show you the impact of those HMOs on the microbiome and the metabolome in the study that I have just discussed. So this was an extensively hydrolyzed whey-based formula, now onto a amino acid-based formula. And just briefly, this was a study from Australia, which was an observational single-arm study, again in infants with the mixed picture of both IgE and non-IgE. But so the outcome was growth of infants with moderate to severe cow's milk allergy who were fed amino acid formula with HMOs. And this is the same concentration of the HMOs. And since it was a single-arm study, the growth parameters were compared to the WHO growth standards. The population of the study was 32 infants who were enrolled about 4 months of age, there's pretty good retention in the study, and they were followed up to 12 months of age. So I think what is interesting in the study is that the manifestation, so both IgE apparently and non-IgE, although we don't have the results of the IgE testing, by looking at the types of the symptoms, there was urticaria, angioedema, but the vast majority of the symptoms were either gastrointestinal, so rectal bleeding, irritability, vomiting, or eczema, atopic dermatitis, so very common manifestation of cow's milk protein allergy. So growth parameters were, so the blue line represents the study infants, the red dotted line, interrupted line represents the standards, and you can see that they sort of tracked nicely over the study period. What was also very interesting was this very prompt symptom resolution. So you can see at baseline a lot of crying, fasting, spitting up, vomiting, feeding problems, skin symptoms, and respiratory symptoms. And then over the first month after initiation of the treatment with amino acid formula with HMO, there was significant reduction in all of those symptoms. So just as a reminder, formula without HMOs also reduced the symptoms in the infants fed with extensively hydrolyzed whey-based formula. So the summary of clinical results of the platypus study is that infants with moderate to severe cow's milk protein allergy, both Ig and non-Ig mediated, fed with amino acid formula with 2-HMO, achieved normal growth with some catch-up growth. During the 4 months of study period, all our anthropometric parameters progressed along the WHO growth reference. Significant clinical symptoms decreased significantly from enrollment to the 1-month follow-up visit. So pretty rapidly, there was a significant improvement. And I should mention that the formula was very well tolerated. There was no adverse events, and there were just 2 infants that reported some abdominal discomfort, but that continued in the study. So clearly, the formulas are having some beneficial effects in infants with cow's milk protein allergy, and Professor Heine is going to take over and tell you why and how this is happening. So in summary, although I didn't talk about lactose, I should mention that it is also a very important component in the human milk. And in addition to HMO, is important for development of the healthy immune system in breastfed infants. And the formulas that, until recently, hypoallergenic formulas did not contain lactose and did not contain any HMOs. Development of allergic diseases is complex, and there are multiple risk factors, but microbial dysbiosis is one of the important risks. Cow's milk protein allergy is immune system-mediated disease, and the 2FL and LNT play a role in protection against allergic disease through several actions. Both whey-based and amino acid-based formulas supplemented with 2FL and LNT were tolerated well, resolved symptoms, and maintained normal growth, supported normal growth despite lower protein concentration. It does have a positive influence over the microbiome and metabolome of the gut in those infants. Thank you.
Thank you very much, Anya, for this really lovely presentation. Thank you. And the last talk by Professor Ralf Heine, entitled Evolving Our Understanding of the Impact of 2FL and LNT on the Gut Microbiome and Metabolome in Infants with Cow's Milk Allergy.
Thank you again for the kind introduction. My task is to now provide some mechanistic background to the observations that we found regarding the infection reduction and what's actually happening with the microbiome in infants receiving HMO supplemented formula. I think breast milk is the gold standard of infant nutrition, and it provides a good guide for any future development in the formula space. So and we know that the metabolic and microbiome effects of breast milk are largely driven by human milk oligosaccharides, and there's hundreds of them, different kinds of human milk oligosaccharides in breast milk. These are very, very important in establishing the early microbiome towards an infant-type microbiome. And this is a point I want to drive home, and I will explain this in greater detail. Until recently, infant formulas did not contain any human milk oligosaccharides, and it's only since they can be made via bacterial biofermentation that we have now the benefit of breast milk identical components that can go into formula. And this is also now followed by a rapidly expanding knowledge about what these actually do in vivo and in vitro. I want to just spend a little bit of time to talk about infant-type bifidobacteria, because this is a distinction that's quite important. The infant-type bifidobacteria you can see at the bottom here are basically 4 species that are very good at assimilating and utilizing HMOs. So the main one, the first one, Bifidobacterium longum subspecies infantis or Bifido infantis, is the all-round master at utilizing HMOs. But the other 3 that you can see there, B. breve, B. bifidum, and B. longum, are also able to utilize bifidos and are typical in the early colonization of the infant microbiome. You can see that these bifidobacteria have specialized transporters that allow to assimilate HMOs, and then have a specialized set of enzymes to break down these HMOs into smaller ingredient sugars, if you like, which are then fermented in the bifidobacteria with the outcome of mainly lactate and acetate as the main metabolites. And it's now very important to understand that acetate and lactate can also be then cross-fed to other bacteria which co-establish in the gut early on. And I just want to maybe draw attention to the conversion of lactate to propionate by Veillonella, which is an early colonizer. And also, very important, the conversion of acetate to butyrate. And you've already heard in the talk by Professor Omani that butyrate has very strong tolerance-inducing and immune-modulating properties directly on cells, but also on barrier function. You can see in the right text box all the different effects that butyrate has on the colonic epithelium, but also on tolerance development. And this is the set of enzymes that we don't possess. So these are glycosyl hydrolases that are bacterial. And you can see that we would struggle to do any of these digestive steps in our gut, but with the help of the bifidobacteria, we can suddenly utilize HMOs via bifidobacteria. And you can see that breakdown products also can be utilized by other bifidobacteria. And once one sort of infant-type bifidobacterium has established, you can see that based on the microbiome, on the HMO breakdown products, other bifidobacteria follow, and they also freeze out other unwanted bacteria by competing around nutrients, and many bacteria can't utilize these breakdown products that you're seeing above. There's also a new discovery on aromatic lactic acids, and these have previously been unknown to be of importance, but these are important immune modulators for tolerance development, and they modulate T-cell responses and monocyte responses. And they are coming from aromatic amino acids, and then an enzyme that was previously unknown until a couple of years ago, aromatic lactate hydrogenase, can actually make these different types of aromatic lactic acids which have immune modulatory function. Now, coming back to our studies, you've heard very nice summaries of these studies. So the first one was the cinnamon study of an extensively hydrolyzed formula with 2 HMOs, and you can see here that it was predominantly a growth study, but that we also saw a trend in reduced respiratory infections. And this is mirroring the findings from a healthy infant study also, which showed a significant reduction in lower respiratory tract infections. The stool collection schedule is shown here. So they had a baseline sample collected, the infants before the intervention, and then follow up 1 month later, another 2 months later, so at 3 months follow-up, and then all infants had a final specimen taken at 12 months of age. And you can see the numbers here of the infants initially randomized, 97 in each group. We had follow-up later to a smaller group of infants where we also looked at metabolome. Looking at what bacteria were actually enhanced or enriched in the microbiome between the two groups, we could see that bifidobacteria and infant-type bifidobacteria here in yellow were preferentially enhanced. You can see, for example, other bifidobacteria, which we also know are beneficial, but for example, here at the lower end, Bifidobacterium adolescentis is not enhanced because it's not utilizing HMOs. So the HMO effect really selects out the right bacteria, bifidobacteria, for the infantile period. We then also looked at how the microbiome evolves over time, and this is done by a so-called cluster analysis where you look at what stages the microbiome goes through, and I won't have time to go through this in detail, but you can see here on the right panel the early colonizers, and you can see that we have sort of 10 or 12 main colonizers, and the gray area above are all the other bacteria, and as the infant ages, diversification happens. We then followed these community types over time, and you can see fecal community cluster 1, 2, 3, 4, and 5, and infants usually go through these towards a more stable fecal microbiome pattern. And we could see, when you can compare the control versus test for each column, that there were significant differences. And basically, what we did is we split the cohort into two infants, because we had enrollment ages from 0.5 months to 6 months, and that to look at microbiome is a huge gradient. So to get a clearer picture, we looked at those enrolled early, under 3 months, where complementary diet is not confusing maybe the findings, and then the later enrolled group, where complementary diet also may modify more importantly. And you can see that we have significant differences, and that the infants who did not receive HMOs ended up with a more adult-like pattern around 12 months. And if you look at the yellow bars here in the early enrolled or in the late enrolled infants, you can see that about 50% of infants in the non-HMO supplemented group had reached an adult-like pattern, whereas only 25% in the HMO supplemented group. And you could argue, why is this important? But if you stay for longer in a bifido-dominated microbiome pattern, you may also prolong the window for early immune modulation. So this may actually be additional time they have to develop normal immune responses. We also looked at metabolites, and acetate, as I showed earlier, is one of the main metabolites. But the signature was maybe not as impressive as we were hoping, and the reason for that is multiple, but we can also see that, for example, the control infants already start at a very high baseline, which indicates that some of them would have had breast milk exposure previously. So it's not a black and white picture, but what we could see is that in the control infants, the early acetate signature goes down, whereas in the HMO group, acetate goes up. And that is almost significant in this setting. And we have to admit that fermentation of dietary fiber at the later visits probably obscures the HMO effect. And that's a technological limitation that we have because infants obviously commence a diet, and dietary fiber is also fermented. So we see a competition of fermentation products. And this is even more complicated, and I won't have time to go through it entirely. But what we looked at is the 16 key metabolites that were altered between the HMO supplemented and non-HMO supplemented formula, and also 17 KEGG orthologs, which are the enzyme pathways that these bacteria have. And you can see all the different enzymes on the right side. And at the bottom, you see the metabolites. And what we saw is two main pathways, apart from the acetate that are short-chain fatty acid pathway. We had an effect in the bile acids, and we could see that conjugated bile acids were decreased. And we also could see that in the amino acid pathways that there was decreased breakdown of branch chain amino acids and aromatic amino acids. So we saw a downregulation of oxidative protein breakdown. What these mean in a clinical setting, I think, needs to be explored, and I can just offer this as a description of what's happening, and I think it needs further interpretation what this means at the clinical level. The second study, the platypus study in Australia, and we're lucky to have some of the investigators here in the audience, was primarily a growth study, but we also looked at microbiome outcomes. It was a single-arm study of about 30 infants with moderate to severe cow's-milk allergy, and it was a mix of a few infants with IgE-mediated features and the majority of non-IgE-mediated features. Again, we did a detailed shotgun metagenomics analysis, so all the speciation of the bacteria, plus also a quick look at short-chain fatty acid profiles, but not as detailed as for the previous study. And the visit schedule, again, quite similar, a baseline sample, a 1-month follow-up, 4 months, and then a 12-month sample. And I show you here now firstly to illustrate that infants, even at baseline, already had different patterns. And if you break down the baseline sample by age, you can see that there's already a transition to different patterns. But what you can see is, if you look at the top level, the actinobacteria in light green, and at the bottom panel, the bacteria, Bifidobacteriaceae in light green as well, you can see that the space that they occupy at baseline is not very big. So there's a depletion at baseline of Bifidobacteria. And if you then look at visit 1, you can see that the light green space in both graphs has expanded, which means that there is a bifidogenic effect, so an enhancement of infant-type Bifidobacteria in response to HMO feeding. When we looked more in detail around the HMO-utilizing Bifidobacteria, there are 2 groups. There's the infant-type Bifidobacteria, so the 4 that I introduced on the earlier slide. There are also 2 others, Bifidobacteria, Pseudocatenolatum and Catenolatum, that can both utilize HMO and dietary fiber. So they're more transitionary Bifidobacteria, which appear towards the end of the first year. And you can see that we had early amplification from baseline to visit 1 of the probably early infant-type bacteria, and then later on a further strengthening of the signal of bifidobacterial enhancement, which also includes the strains in under 5 and 6. So we do see an enhancement, and I also want to draw your attention that some infants at V0 did not have any bifidobacteria that could utilize HMO, and could also not amplify bifidobacteria as we went along. And this is an important fact to also bear in mind, that some infants have a very deranged microbiome and may not be able to utilize HMO anymore. Finally, we did a taxon set enrichment analysis, and that compares just which bacteria are the most enhanced or the most suppressed, and I won't have time to go through this in detail, but we saw that Bifidobacteria, Lachnoclostridium and Bacteroides were generally enhanced, and you can see at what levels that was significant, whereas some abundances, for example, E. coli and Klebsiella, which are proteobacteria, were reduced. So we see a picture evolving of increase in early stage Bifidobacteria or HMO assimilating Bifidobacteria, and a reduction in proteobacteria, which is really the opposite of what describes the dysbiotic stage. So we see a partial correction of microbial dysbiosis. And just finally, very briefly, we could not distinguish fiber effect from HMO effect because it was a single arm study, but we can see that the infants had a significant increase in acetate from visit 0 to visit 1, which could be attributed to an HMO effect. And we also see that butyrate and propionate rise later on, hopefully, or most likely, due to a mixed fiber and HMO effect and cross-feeding, for example, of acetate into butyrate by butyrate producers, which we also saw emerging, and I won't have time to go through that in detail. So in summary and in conclusion, We saw in infants with cow's milk protein allergy that breast milk identical HMO promoted an enrichment in infant type bifidobacteria, and the stress is really on infant type, so these are very specific HMO utilizing bifidobacteria, and a reduced abundance of proteobacteria, suggesting a partial reversal of the dysbiosis that we see commonly in cow's milk allergic infants. We also could show that HMO supplementation slowed the premature shift towards an adult type microbiome, and we saw some metabolic signatures changing, mainly regarding fecal acetate, but also bile acids and amino acid breakdown. But clearly we also need further well-designed studies to look at these immune modulating effects and metabolomic effects in greater detail. So there's a lot of work ahead of us. Thank you very much.
Thank you very much, Prof. I would like to invite the three speakers to join me here on the stage, please, for the question and answer session. And this is now open for discussion, so please use the microphones in the room to ask your questions. And I think I will get started while people think about questions. So, at what stage of the infant's immune system development are HMOs most important, and particularly in non-breastfed infants? What is the key window? Maybe, Anya.
I think the earlier the better, right? Like we saw the best effect when they're breastfed, or like you introduce formula with HMO since birth, essentially. So, and we know that the first year of life is the most critical. I think HMOs are important. Well, the HMOs, maybe, yeah, the first, I mean, like physiologically, right, during breastfeeding. So first 6 months of life for sure, but the earlier, I think the higher importance.
Oh, okay. Okay, can you?
I think it's easier for everybody. I'll be loud.
Okay, great.
So why, the question that I always have in my mind is that whether we want to know it or not, breastfeeding does not protect against food allergy. And so I struggle to understand why we're always trying to mimic the infant gut to look like that of a breastfed baby for the prevention of allergy and food allergy. And there may be a transient effect on atopic dermatitis prevention with breastfeeding, but for the other allergy outcomes, we don't see anything, particularly nothing for food allergy. So can you explain that to me, please?
Thank you very much, Karina. So, Prof, you want to take that? Quite provocative.
Yes, so I think breast milk is our gold standard template. I think this is tested through thousands and thousands of years, and is the survival strategy that we have as infant. And I think that the infection benefit may be the one that is evolutionary of greater importance, and that's gastrointestinal infection and respiratory infection. But so the allergy problem is the sort of recent hit on the block, and so whether breast milk is adapted to prevent that entirely, we have to see. But there are other things that come into, like antibiotics, and so it is a complex picture. But I think the immune modulatory effects of breast milk and HMO, early HMO, are probably the best guess that we have at the moment to promote tolerance development and to prevent allergic disease. And butyrate is probably one of the key players here, but is it going to be 100% protective? Probably not. But I think not having anything in formulas, talk about formulas now, is probably not ideal, because then you end up with more prolonged dysbiosis. And I think it also highlights for cow's milk allergy, if you're aiming for outgrowth, that your intervention has to come early, so you have to have an early diagnosis. And so these are all things that we have to work out, but obviously we don't have all the answers just yet.
Thank you. Thank you very much. We have another question there, please.
Roberto Benicanani from Naples, Italy. Just to add more concept to the discussion that Karina opened. Have you got some data regarding the influence of the quality of the diet of the lactating mother on the presence and the abundance and the level of these beautiful compounds? because this could be the solution. Because if you are continue to analyze mother drinking or eating junk foods, maybe this factor could decrease the abundance of this protective compound. This could limit the potential of breastfeeding in protecting against the occurrence of a food allergy. So maybe it's better to investigate in a good detail the presence of this compound, but in correlation with the dietary habits of the mother, the age of the mother, the smoking habits of the mother, the sport activity, and many other factors could influence the presence or the absence of this kind of stuff. But the question is, did you look at innate and acquired immunity compounds in the stool sample that you collected? Because this could be the explanation why these children experience less infectious diseases.
Question or comment? I mean, this is certainly something that we are looking at. So the aromatic lactic acids, which have emerged as a new candidate, immune modulatory candidate, they were not discovered when we designed our study. So they were not on the radar. But I think that these and butyrate and short-chain fatty acids and other maybe yet unknown metabolites could be markers. And I think to your question or your comment on breast milk composition and HMO composition and maternal nutrition, obviously that is an effect, but for example, malnutrition alters breast milk composition, and we also know that there are strong genetic differences between mothers, and that 20% of mothers, for example, as non-secretors don't make much 2FL, which could, for example, also alter immune responses. So I think there is breast milk is not equal breast milk, and different stages of breast milk also may confer different composition in HMOs. So I think it's a very complex picture, and to mimic all of this in formulas is a big ask, yeah. But I think we have to start somewhere, and we're seeing very encouraging results now in the infection space already. And I think the next frontier will be what happens with regard to tolerance development, either immune modulation, reducing allergic symptoms, or faster outgrowth. I think that's of great importance.
Thank you. I think we have got a question there. Can you either come to the microphone here in the front or shout out, please? Either.
Hello, Amina Warner from Allergy UK. Mine's a much more practical question, really. A lot of mums, when they make up feeds and things, put these shots of boiling water in. Does that destroy, the boiling water if that just came onto a feed with HMOs? Would that destroy the HMO?
Well, firstly, boiled water is not recommended, if I can say that. So 70 degrees, boil the water, but let it cool to at least 70 degrees, and then make up the formula. But I don't think there's a significant effect on HMO composition.
Yeah, because many mums use machines that just press, and it comes to just boiling water comes first, and then they top it up. Yeah, okay, thank you.
Thank you so much for your question. So maybe I can ask a question to Liam. What are the immune mechanisms of this effect in the prevention of infection or reduction of infection and reduction of medication use in infants having HMO in their formula or breastfeeding?
So I think, and I guess to comment on where the discussion was before this as well, I think the epigenetic landscape of the immune cells is what's critical early in life, and they have to get from this stage to this stage, and they start that in utero. So that already depends on mum's diet and mum's exposures, and then they're born at somewhere along that line, and then they need to get to the end within a few months. And those factors that promote opening up of the Th1 type of immune response and the closing of the Th2, I think that timeline is really what's critical, and that Th1 response is what's needed to deal with infection, and closing of the Th2 is what protects against allergy. So many factors will do that. Microbes are one, bifidos are one, short-chain fatty acids help, breastfeeding helps, but actually I think you need many of them to really get there as quickly as you can. And I think that's maybe one of the reasons why breastfeeding from an allergy point of view is on its own not significant. But when it comes to infection, it really is. So maybe that's telling us it's directing more of that Th1 type of immunity rather than blocking of the Th2. Maybe. Let's see.
Great. I think we are running out of time. I had a couple more questions to Anja, but I think we are running out of time. And so I'd like to close the session and thank you very much to these excellent speakers and thank you all for attending.